Okay, here we are. Wrapping up Chapter 3 on an asynchronous Friday.
I like asynchronous Friday because I get to be in the videos.
Stat, you're already on the screen. Can you just chill out? We got to cover what we're hitting today. So Chapter 3, what's left? Well, we're going to revisit some examples just for review. The payoff tables and the trees, perhaps. We'll look at the payoff tables first. We're going to talk about value of sample information. We did talk about perfect information, didn't talk about sample yet, and that's going to be pretty short. And then we're going to run through just a few new problems, mostly in trees, just to let you get some practice making trees. So let's first go look at the payoff tables for these other problems. So here we are. Just to remind us, this is where you should somewhere have a complete solution for the original restaurant problem. Remember, the decisions you have are in the rows, the future states of nature are in the columns. This is all input. I didn't highlight it with a color code for that, but the payoffs are essentially given information. Similarly, the probabilities are given information. We can do sensitivity analysis on the probabilities, but that's given information. Everything else on here is a calculation, including the regret calculation. I noticed a couple of people who showed me problems with theirs. That was the problem, so look at that formula. I will put this solution file on Schoology, so you'll see it out there, but look at the formula and go back to what it said on the PowerPoint slides, that regret is the maximum, the best outcome under a particular state of nature minus what you did. There certainly should be zeros. We talked about that. If you chose a smaller restaurant and zoning doesn't change, you made the best decision. You have no regrets. And the other calculation should follow through. Then we expanded that for the crop selection problem. Again, this really is input. Everything else is a calculation, and you will again see zeros in the regret. Because if it is a dry season and you chose crop 3 at the end of the season, you have no regrets. So remember, regret is what's the best you could have done once you know the future versus what did you do. And that formula works and gives it to you. And also, this is one, just to remind us, had the rather creative mixed reference. We didn't lock B3 or B6. We locked the 3 and we locked the 6. We didn't lock the B. You lock different parts, and different kinds of formulas will do that in different situations. For this one, to go from the restaurant problem to the crop selection, we inserted both rows and columns, 2 rows and 1 column, because we had four choices instead of 2 choices and 3 future states of nature. The same problem then goes for the insurance one. We did this as a tree in class, but we didn't, I don't think, show the payoff table. This would have been one insert if you go from the original restaurant problem. One inserted row, one inserted column, or you can take the crop problem and remove a row and leave the rest of it alone. And the other formulas all work out the same way. Again, if you knew at the end what's going to happen, if there's any kind of damage at all, you will be very happy that you chose a no deductible insurance policy. It is your cheapest option. Of course, if there's no damage, you would have been happiest taking the risk of no insurance. The expected value of perfect information is kind of interesting in this one, though, because it's huge. The expected value of perfect information on one of the problems here, of course, is you could argue about the calculation, whether this should be positive or negative. I think positive still works. The original problem had a $1,750 expected value cost, and it says we can really wipe that out. Well, why can we wipe that out? It's worth pointing out the extremely small probabilities of extremely high damage versus the large probability of no damage. So back to, if you had perfect information, you would be aware of that and you could save yourself a whole lot of money. Over in the crop problem, the probabilities really weren't so wildly different. And frankly, even the best to worst payoffs, look at your regrets, they're not that huge. So perfect information wasn't worth that much. And of course, you can't get perfect information. So what would you pay for better weather information? A lot less than $4,000. Here you'd pay a lot if you could somehow know the future and know that there would be no damage at all. So we'll take a pause there.
Pause, see? Get it? Pause?
That was not a pun, Stat. That was really P-A-U-S-E. Take a pause.
Okay.
So look these over, and then we'll look at the trees for these, and then we'll move on to some other problems. Okay, let's look at the trees now for these. We've seen this before. Just a quick reminder that this is the tree that goes with the basic restaurant problem that we saw. I don't know if we saw the tree for the insurance problem in class. I can't remember. But that's the third sheet on this set of examples. One thing I want to point out, we talked about in class how badly the insurance company seems to have mispriced the risk here. Because normally the lowest or the best expected value for you is to not have insurance. The worst expected value for you is a deductible based policy because the insurance company is taking on the risk and they're going to charge you for that. So either policy has a lower expected value than going without insurance. Kind of wild, but it does show up that way. Here it says, okay, they've mispriced this, so you should get the policy with a deductible because it's going to cost you $1,000 and then there's only an expected value of $750 worth of damage. So negative $1,750 is the total expected value. The no deductible, it's absolutely guaranteed to cost exactly $2,000, but that's more than this expected value. And completely running on your own without insurance, the risk, the probability of damage and the amount of damage is so high that it's a $3,000 negative expected value. So it says do that. So the tree agrees. Now the crop problem, I don't believe that we did this problem in class. So let's open up, rather than work from scratch, open up, I don't know, any of these really. You could start from scratch, no problem with that. But I'm going to work off of this one. And I'm going to show you why I want to do it this way, because I'm going to do the copy and paste thing. I'm going to have 4 crops I can choose from, and I'm going to have 3 different future states of nature. So I'm going to delete this. You'll see why. And you can fast forward to this if you're comfortable with it, but I wanted to show you the basic reusing or rebuilding and using copy and paste for a tree. So our options were for the weather, dry, with a probability of, I believe it was 0.2, I'll double check this in a minute, moderate, and that was a probability of 0.5, or wet, and that was a probability of 0.3. Let me double check those. Dry 0.3, 0.2. I got them backwards. Okay. And what I should have done, as I said in class, is leave that last one at an auto calculation. Dry 0.3, moderate 0.5, wet 0.2. It's complaining because I don't have a payoff on one of these. I'm just going to put in 0 for now. I'm going to put the payoffs in later. The reason I'm doing this is I have 4 different crop solutions. I'm just going to take off this edge label because it doesn't make any sense right now. And it's payoff. So it's crop 1, crop 2, crop 3, crop 4. Since that's the exact same probabilities for the different types of weather, although different payoffs, I decided to build that piece of the tree once and copy it. You don't have to do that, but I wanted to go ahead and show you that. Again, fast forward to this if you're perfectly comfortable with it. Now, this is crop choice. Crop 1, I'm going to go through that. Crop 2, crop 3, crop 4. So all I need to do now is go into here and put the payoffs that you can see here. That'll take a little bit of time, so I'm going to pause this and type them in. I'll do one of them so you can watch, but I'll pause it. You can do the other ones on your own, and then we'll come back and see the results. So I need to get these numbers for crop 1, dry, moderate, wet, 25, 35, 40 onto this. 25, 35, oops, wrong place, 25, 35, 40. And I'm not even reading my own spreadsheet very carefully. It's 20, 35, 40. And you should have the spreadsheet. It's on Schoology. So, my own typos. But then we see the expected value. It does match the expected value calculation, 31.5 if I choose crop 1 and given that distribution of weather. So I want to type the next 4 in on for this branch, the next 4 in all the way down. So this I really will pause and do those, and then you can do it on your own. So I'm going to move the silver decisions tree a little bit differently. Try to squeeze it into my recorded window. Get this into there. So you've got, hopefully it matches. Crop 1 has an expected value of 31.5, crop 2 30.75, crop 3 26.5, crop 4 20. I will put this, all 3 of these trees, well, this one you've already got. I don't know if you have this one, so I'll put this insurance tree and this crop tree in the Friday folder so you have it along with this. But I wanted you to see it. You should be able to create this on your own. So I'm not going to try to squeeze it down on the screen so you can see it. All of these, of course, are fairly straightforward. They're a single decision leading to an uncertain thing that happens and then various payoffs. So that's why all 3 of these go pretty well from the payoff tables into a fairly straightforward tree. So what's next? Again, we're going to take a break. I didn't say pause. Control yourself stat. Then we're going to talk about sample information, valuing it, and then we're going to look at some problems with more complicated trees.